Okie dokie. Haemostasis Slice 3. So we've already said that under normal conditions, the vessel wall, we said, and the whole vasculature is going to be trying to maintain normal blood flow. So how does it do this? We already said back in Slice 1, the idea there is to make sure that the vessel is as large as possible, because Poiseuille's law relies on pi r4, r to the 4, and that means that the wider we can get the vessel, the greater the flow. Why is the flow greater? Because resistance drops. So resistance to flow drops, therefore flow increases. Okay? So in the normal conditions, the vessel wall and the vessel itself is going to be anti-thrombotic. Okay? So the vessel is going to be anti-thrombotic. How does it do that? Well, basically, it synthesizes synthesis, and it secretes them. Secretion of coagulation inhibitors. So we'll just say inhibitors. Inhibitors to what? Inhibitors to hemostasis. Okay, so what are these? Largely, these are going to be nitric oxide and something called TPA, which stands for tissue plasminogen activator. Sorry, I just sold you a dummy then, because this should be a capital A. TPA. Okay, little t, large P, large A. Okay, so we said that the next thing that can happen is is trauma. So under trauma, what happens? We said that's when we need to form a clot. Why do we need to form a clot? Because we want to keep our blood inside our vessels. So it becomes not anti, but pro-thrombotic. Okay, pro-thrombotic. So now, rather than synthesizing and secreting inhibitors, the vessel is going to do something else. It is going to promote primary and secondary hemostasis. Now it does that because when we get this trauma, what we end up getting, so if we just do a very basic blood vessel like this, okay, the endothelium there, what happens when we have trauma to our vessel is, I'll just pretend that this is going to be doing our trauma, is that we get a break in the vessel. And what that does is it exposes all of that tissue that was underneath the endothelium. So it exposes the tunica intima, the tunica media, and all of those lovely, lovely things that sit inside there. Now, when I'm saying all those lovely things that sit inside there, you're probably thinking to yourself, well, what is that? Well, I'll tell you all about it when the time comes. But for now, what you need to know is that everything that is going to be coming through there, and indeed out of these cells that are also damaged, all of those things are prothrombotic. The two chief ones that we're talking about are not nitric oxide, but, so, do we say exposes the subendothelia, or do we just say we'll leave it over there. Now we'll leave it over there because we've got two things to talk about. We've got endothelium 1 and we've got a big thing, and this is going to be the key to everything. Tissue factor. So this promotes make sure I do this in capital letters because otherwise you're never going to read my handwriting. Vasodilation. And this promotes fibrinolysis. This guy promotes vasoconstriction. And this guy promotes coagulation. And coagulation is synonymous with secondary hemostasis. So we can see that actually when we talk about these things being primary, secondary, and tertiary hemostasis, what we're doing by priming our vessel to form a clot is we are doing primary hemostasis. But even in primary hemostasis, we're taking steps to ensure that secondary hemostasis is going on, and when we were keeping the vessel in normal conditions, tertiary hemostasis was going on as well. So there's never really a time when all of these things exist in isolation. However, it's always worth noting that we teach them that way. Why do we teach them that way? Because it makes things easier. It's easier as humans to think about things in isolation. Okay? So this is kind of the second part of our overview. The next thing we're going to do is we're going to start talking about what it is that is under here that is going to come up into this space and make things start really progressing along with primary hemostasis. It's a particular protein. It's called von Willebrand factor. And that's probably the last time that I'm going to pronounce it correctly, because from this point on I'm probably going to call it von Willebrand factor, but technically it's von Willebrand factor with a V. So if we've got any native German speakers listening to this, I apologise for the butchery of your language. I'm going to continue butchering that language in slice 3, slice 4, in the next slice.